Hello and welcome to the Appary.io channel. I'm Alex, and today marks the exciting kickoff of our new tutorial series. We'll dive into connecting an external data source to your app and showcasing it through REST APIs. So, whether you're aiming to view, edit, or store data, you're in the right place. In this episode, I'll walk you through creating a relational database and seamlessly integrating it into your Appary.io project with API Express. Plus, we'll even test our database connection live. Let's kick things off by setting up an external relational database. Today, we'll go with PostgreSQL, courtesy of Amazon Web Services. I'll leave the link to it in the description section. I've already prepared my AWS account, so let's get started. After successful login, access the Amazon Web Services console. Here, select Database, then RDS. On the next page, click Create Database. Select the standard Create Database creation method. For the engine version, select PostgreSQL. In the Availability and Durability section, choose Single DB Instance. Then, type a name for your DB cluster. I'll leave it as is. Under Credentials settings, select the Self-Managed Management type so that you could create your own master password. Then, confirm it. Go to the DB Instance Class section, choose Burstable Classes. In this example, I am using this one. In the Storage section, click to select the Storage Type option and define the allocated storage value. Now, scroll down to Storage Autoscaling, unfold it and disable the Enable Storage Autoscaling checkbox. In the Connectivity section, select Create New VPC, set the Public Access option to Yes. For the VPC security group, enable the radio button to create a new security group and enter its name. In the Monitoring section, I'll also disable the Enhanced Monitoring options, as I will not need them. Scroll down to the Additional Configuration section, unfold it and enter DB1 for the initial database name. Then I'll disable the options I am not going to use. Remember, we're tailoring this setup for our testing needs, so feel free to adjust according to your project. When done, click Create Database and wait until it's ready. When the database is created, let's select it and scroll down to the Security Group Rules section. And then click the Inbound Security Group. Select the DB Security Group in the Inbound Rules tab and click the Edit Inbound Rules button. Choose the Anywhere, IPv4 option for its source. Click Save Rules. Your inbound security group rules have been successfully modified. With our database ready, it's time to add a table. For this, pgAdmin is our tool of choice. It's user-friendly and completely free. If interested, check the description section for the link to their official site. I've installed it on my machine, so let's jump in and start crafting. In the app, click Add New Server. Enter the server name, for example, AWS_test. After that, click the Connection tab and enter the host name/address. It can be found in the AWS Database Connectivity and Security section as the Amazon Database endpoint. Then, for Maintenance Database, enter DB1, for username, Postgres. Provide the password. Finally, click the Save button. Now, in the AWS_test tree, click Databases, DB1 Schemas, Tables, then right-click, Create. In the new window, enter the table name, for example, Test, and switch to the Columns tab. Let's now add the columns to the table by clicking the plus button and defining their names and types. In my example, I need two columns, ID of the integer data type and name of the character varying data type. Click Save. Once set, we'll populate it with some sample records. In the pgAdmin application, right-click on the table, here it's the test table, then select View/Edit Data, and then click All Rows. In the new page, enter some data into the fields provided. When done, click the Save Data Changes button. Make sure that the table has a primary key defined, it's important. Great, our database is not just a standalone entity, it's time to make it part of something bigger. Let's go to the Apery.io app builder and create an API Express project to check how our model works. Go to the API Express module where we will connect our database and share it through REST APIs. We'll start by creating a new database connection. Click Create New DB Connection. It will be a relational database, so keep this option selected. You can see that Apery.io supports 4 database types, but since I'll be using the database I just created as an example, I'll select PostgreSQL. You can also see that we offer 2 settings options, Basic and Advanced. The difference is that in the Advanced mode, you can additionally provide the JDBC URL, but in most cases, going with Basic is the best decision, so I'll stick to it. Next, let's provide information about the database, all of which is pretty standard. First, enter the external database host. Go back to the AWS Database Connectivity and Security section, copy the Amazon Database endpoint and paste into this field. Then, at the database name, I have DB1. Then, username, in my case, it is Postgres. And then enter the password you provided for the database. Before you proceed, test the connection. Everything is okay, so let's save the connection. Next step is creating an API Express project that will expose the data kept in the connected relational database. Click Create New Project. This API Express project will manage all the APIs that can be used in any mobile app. Enter the name for the project, for example Amazon Test Project, and click Create. Now, we need to create a service. In the project, click the New Service link. You are offered 2 options, creating your custom REST API service or generating it automatically. The first option is more complicated, so let's now see how to generate the service automatically. You just provide the name, select Generate REST API and click Create. In the new window, select the connection we just created. Next, select the test table we created in the pgAdmin app. API Express automatically loads the table data, all its fields and type. Note that only the tables with only one primary key value defined can be added. So, make sure it is defined for your table and it is the only key available. In the Actions section, you can select the services that will be used. By default, all of them are enabled, but if you want to remove the option of deleting your records, uncheck the Delete checkbox. Now, let's see how you can define the table settings. For example, you can select what column must be included and what excluded from the output. You can rename the columns you want to return if you need. Also, you can select the column you want to sort by. Additionally, you can define the sorting direction. When finished, click Generate Service to add the model. All the needed services are created and can be tested. Click the test link to open the service test page. Scroll to the Request Payload section and in the Find tab, delete the default request data to invoke the service. Find all the available records, then click Test Service and check the Response tab. All the records are returned. Let's first add sorting to our request and ask the service to return only specific data. For this, add the requested payload and click to test the service. Only the needed record is returned now. Now, let's take a quick look at the parameters you can set to get the needed output for your service. If your database is huge and you want to limit the number of records to be returned, you can set the limit in this field for pagination. You might also need to add offsets or, for example, return the record number count. In the Sort By field, you can enhance the sorting options and define, for example, 2 or more table columns you want to sort by. Similarly, you can define all the added services to customize how your app returns database data. And that's a wrap for today. We've created a database, prepared it for mobile app integration, and exposed it through REST APIs. This is just the beginning, so stay tuned for more tutorials. Don't forget to subscribe to our channel and sign up for Apery.io to kickstart your app development journey. See you in the next video, and thanks for watching.